Hello, everybody. This is Mr. Tam coming back with another episode as we continue on our lessons even during this difficult time. So, today I'd like to introduce to you what we call the magnetic field of a straight wire. So, last time, just to recap, we were discussing magnetic field shapes and direction of a bar magnet. So, you essentially had a bar magnet that had a north and a south. And as I talked about last time, you had something like a double rainbow that happened, occurring from north and going towards the south, much like we fly away during winter to head towards warmer regions. You leave the north to head towards the south. Now, that being said, we're going to now move on to something a little more difficult in the form of a straight wire. Now, as we learned earlier in the year, we know that electrons are subatomic particles that are what in charge? They are negative in charge. So let's remind ourselves of that. E with a little negative. Now, when these electrons go through a wire, something really interesting happens. Electrons, when passing through a wire, will suddenly be able to generate a magnetic field around this wire. So if I had a wire, let's say, straight across, and one end here was positive, and the other end here was negative, you would have electrons going from negative to positive. Because, as we said, electrons are negative and therefore are attracted to positive. Now, how do we figure this out? The direction. Well, first off, we're going to figure out the shape. And the shape of a magnetic field is actually very simple. It's actually just a circle around the wire. So let me illustrate this. It's essentially a circle around a wire. And this circle will have a direction attached to it. And to figure out this direction, we do this. So as you're watching this, you're facing your screen, the positive should be on your right, and your negative should be on your left. What I'd like you to do is extend your left hand forward, and we're going to stick our thumb out so that it points in the same direction as the positive. Now, everybody should have their left hand out with their left thumb pointing towards the right. We now have our fingers free. Those fingers will then wrap around the wire. And if you can't visualize this on the screen, please take any writing instrument, be it a pen or a pencil, and put it underneath your fingers. Now wrap your fingers around that pen or pencil. And this will essentially show the direction of the magnetic field. Now this magnetic field, if you did it properly, should be heading up, to the back, downwards, and towards you, just like this. Let me illustrate that on this side as well. Remember, it's a circle around the wire, and you have the field going around that wire. So it's essentially a circle. The other way that you might see it on an exam or a test or a quiz is this weird trapezoid I just drew that represents essentially a flat surface. And you're going to have, let's say, a wire that passes through it. And I'm going to go through again what we learned a couple of months ago, where you had essentially this symbol that represents a power supply. Now remember, the short end of the power supply means that it's negative. So the electrons start there, and they're going to essentially move around this circuit, following a direction like this. So the electrons are moving around in this direction. Now, how do I figure out the direction of this one? Well, if we follow the same flow of electrons as we were talking about earlier, in this case, I'd like you to, facing your screen, point your thumb upwards because that's the direction of the electron flow. You're essentially pointing your thumb towards the positive. And now I'd like you to wrap your hand or your fingers around that wire that's going straight up. So if you're not sure, I will do a live demonstration afterwards. But essentially, you're wrapping your fingers around that wire. And again, because this is a circle, we're going to represent that on the flat surface. And you can see that your fingers are actually forming around this direction. From our perspective, we can essentially call this clockwise. Try not to use those terms, but because depending on the way it's facing, the wire, it's coming in or out of the page, it's going up or down or side to side, we don't want to use those terms too much because it could lead to confusion. But in this particular scenario, right here, you have the magnetic field going in a clockwise direction. Now, before I sign off here, guys, it's really important to remember is if they ask you about putting a compass. Now, let's say I put a compass on this flat surface. Well, as we were looking at in the last video, this direction of the magnetic field is essentially the same direction as the north. So what you actually end up with is a compass that looks like this, where the arrows actually will form the north side of the compass if you were to put a compass flat like this. So that's really, really interesting. The last thing I want to do before we sign off is just to demonstrate to you what this looks like. So if I were to have a wire that's going, to the side, let's say your electrons are going this way, what I'd like you to do is, again, we're going to take our left thumb, I'm going to point it in the same direction as the electron flow, and as you can see, my fingers wrap around that wire, leading to a magnetic field that looks like this, a circle around going towards you. Now, if I were to have a flat surface, for example, look at this card as just to demonstrate. Now, this is my flat surface. I'm going to have my electron flow going up. And what I'm going to do is I'm going to take my left thumb and I'm going to point it upwards. As you guys can see, my fingers actually wrap around the wire here, and you can see that the electron flow goes in the clockwise direction. So that's pretty much it. Not more complicated than that. I just wanted to give you all the varieties that you might see if ever something like this comes up on a test or a quiz. And I hope you guys are well. We'll see you in the next video. Take care. Bye-bye.